All right, here we are, Unit 8 review. The test will be Thursday and Friday. There's 8 problems, multiple choice, and there are probably, I think, probably 15 or 14 free answers. All right. Everything needs to be turned in the test day, including the review and any missing assignments or quizzes. And then next week we will be doing a project, like a very small unit. We're going to spend one day, and then you're going to do a project by yourself. And then we will get started on term 4 information. So unit 9 will start next week. The term will end on a Friday from this Friday, a week from this Friday. And but we will get started, and all of that will count towards the next unit. So this test will be on this unit. Okay, all right, so let's go over some of these really quickly. You can always review by looking at previous videos and asking neighbors or stopping by. Please, if you can, stop by or ask your neighbor so you can understand. Okay, also there's lots of things that you can look online as well. If you don't know how to graph absolute value functions, then just search Google absolute value functions. Okay, you should be able to do that pretty easy. And I really like this website called Khan Academy. You can look up pretty much anything and it will give you examples and you can practice. So that's another option. Okay, so here we need to do 1 through 4. They give us wording and we need to write down the equation. So this one says write an equation for an absolute value function. Absolute value function looks something like this. Okay, a quadratic equation looks something like this. Okay, so they look very similar. They both have h and k, that's our vertex. And a gives us our growth pattern or our slope. All right, so here we'll continue. It says it's reflected over the x-axis. So that means that a is negative. And then it says that it's stretched vertically by a factor of 4. So that comes from that. If it was compressed, this number would have had to been less than 1. All right, and if they didn't say anything about reflecting over the x-axis, then this would just be positive. All right, next, x minus. Okay, so it says it is transformed 3 units to the right. So if it's going right, that means that h is positive, so h equals 3. So we'd plug that in. And oftentimes you may just be realizing that, 3 units to the right, so we're just going to plug in -3. Okay, when you plug stuff in, it's just because of our original equation has a negative in there already. Okay, and then at 6 units up, so plus 6. So h will tell us left or right. Okay, and k will tell us up or down. That would be our equation. Okay. 5 is the opposite, so we need to write the wording. So this one, we would say this is a quadratic equation that is reflected. Because this is negative, we know that it's reflected over the x-axis. Okay, and this number, since the absolute value of a is greater than 1, it is vertically stretched by a factor of 2. Okay, and then finally would say it is shifted, or you could say transformed. Right 4. So whenever you take something out, it will switch its sign, aka h here is 4. Shifted right 4 and up 6. 16. Okay? All right, so if you have any other questions, let me know. One thing is for the answers that I gave you in class, this problem, I guess that has nothing to do with the answers. This should be 1/2, not 1/2. I mean, it should be 1/2, not 2. Gosh, okay. Okay, next, write an equation for the function shown for numbers 9 through 12. So here, all of these, when they're quadratics or absolute value functions, we're always going to have a vertex. So here our vertex here is 3, -4. This other one, our vertex is 0, 4. And would need to find the a value. So a here is, we go over 1, down until we get it. That would be -1. And it would be the same for this one. -1. Okay? So, and then we use those values as we have shown up here. So I'll just circle that. Okay? So we'll just plug those in. That would be our equation. And I'll leave that to you. Okay, same with 11 and 12. 13 and 14. So we want to find the average rate of change, aka the average rate of change is like the average slope. Okay, and the average slope, the rise over run, okay, for these problems is the point slope formula. So y2 minus y1 over x2 minus x1. Okay, and they already give us, when they give us an interval, these are our x1 and our x2. Just zoom in a little bit. So this is x1, x2. We want to find out what y1 and y2 is. And whenever we have an x value, we can always plug that into our equation, and that will end up giving us our y value, okay, the corresponding y value. In class, oftentimes I would write it as f of 2 equals 5/3 times 2 plus 6. And that ends up giving us, I have that, times 2 plus 6. And that gives us 28/3. We do it with f of 5. We do the same thing. You want to probably use your calculator, and you would get 1 second. Sorry, I thought I had this already. Gives us 43/3. Okay, so this would be like our y1, y2, and then you just find the difference between those two, which is right here. That ends up giving us 5, and the difference between our x's, which is like this, is 3. And so have it as a rise over run, that would give us 5/3. And that makes sense because our equation is, oops, I went a little too far. That gives us is the same thing. These are equivalent, and it should be because this equation is a linear equation, and the average rate of change for a linear equation is constant. So doesn't matter what your interval is, it will always, your average slope is 5/3 for this problem, okay? So on the test, if you realize that it was a linear equation, then you would just say 5/3, and then you would need to explain how you know. Okay, so you could say something like linear equations have constant slope, and that would be fine. Something like this, where it is a quadratic, you would need to do these types of this work and plug it in and get your answer. Okay. All right. So 15 through 16, they want us to find what the maximum value is, or which one is which two equations has the highest maximum value. So here, first one, you would maybe want to graph, okay? Or if you couldn't graph, We can graph and we can find the maximum that way, or we would use the equation of the vertex, which is negative b, oops, mess that up, negative b over 2a. That gives us our axis of symmetry, and then we plug that in to give us our maximum or our minimum, okay? And that is what we called is the vertex, that x and y, h and k, okay? Same thing. Anyway, so you'd plug that in, and you would end up getting something, so you do something like negative b, negative 2 over 2 times negative 3, which is our a. That ends up giving us a positive 1/3. And so we'd plug that into our equation, y equals negative 3 times 1/3 squared plus 2 times 1/3 minus 8. And you would end up getting 7.66. Okay, so there you would find, or negative 7.66. So we want to find the maximum. So that's one of our maximums. And then we want to find the maximum for b. Well, this one is in an absolute value function, which means that our vertex is our h and our k. So our vertex here would be negative 4 comma negative 3. And this would be our maximum. So since negative 3 is greater than negative 7.66, we would choose A. Okay? And then you do the same with like 6. And we've done some of that from our homework as well just recently. Next, 17 and 18, we need to answer the following questions. So this is an exponential function, which is y equals a times b to the x. But remember, whenever you have a number in the exponent, we need to simplify it. So we would want to find out what 1.38 squared is. So 1.38 squared on your calculator, that ends up giving you 1.9. So your equation here will be 350 times 1.9 to the t. Okay, so there now you can answer your questions. So initial value is 350. Growth, yes, because this is greater than 1. If it was less than 1, it would be decay. And then the growth factor is 1.9, and the growth rate here would be 90%. So the difference from 1.9 minus 1 gives you 0.9 or 90%. Okay, all right, so you do the same thing with 18. So just remember that we have a number in the exponent. We need to take care of that first. All right, 19 through 22, we need to write down if it's linear, quadratic, exponential, or none of the above. So I'll do 19. Hopefully you can figure out 21 through 22. So this one, what you'd want to do is you would want to find out the first difference. So here the difference between these two is 3. Difference here is 3. Difference here is 3. Difference here is 3. So I would always start by taking the first difference. If the first difference, if this is not constant, if they're not all 3, then we'd go on and do second difference. Perhaps it's quadratic. If the second difference is the same thing, then we'd say it's quadratic. I keep writing my Q's backwards. Quadratic. This one isn't because this is linear. Okay, and then if either of these didn't work, then you would maybe want to see if it's exponential. And if it's exponential, then there would be a multiplication between each y value. Okay, I'll do some more of those when I get to that at the end. All right, this one, we want to calculate the worth of a Chewbacca. So Tom purchased a Chewbacca in 1977. I think this is one of the first ones. It only cost $4, but the value increased, or has increased by a rate of 18% per year. How much will the Chewbacca be worth now 42 years later. So we'd want to write down an equation for our exponential growth, which is a times b to the x. A is our initial value, so this is our A. B is our growth or decay factor, but what they give you here is the growth rate. Okay, so we can't plug that in directly. If we look at our equation here, our growth rate here is 90%, so we'd want to do the opposite of what we did before. So we'd do like 0.9 plus 1 to give us our growth factor. So same thing here, you would do 0.18, which is 18%, and we'd want to add it to 1. It would give us 1.18 would be our growth factor. Okay, so our equation here is going to be 4 times 1.18 to the x, which makes sense. If we had it be 0.8, this would actually be decay, and we don't want decay, it's growing, okay, it's increasing. So here we would just plug in 42 years for x, and we would get our answer, okay. It's very similar for this one. The answer on the review answers is incorrect for B and C. So I will try and remember to write that or let you know about that at the end. This one, 50 or 225, you just need to write down some sort of situation that could model this. Okay? And we've talked about that before. If you have questions, let me know. You could have like a guy climbing up something, blah, 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 blah. Come up with, make sure you explain how this goes negative. Be unique, or yeah, be unique, I guess, yeah. Okay, these ones, evaluate each function at a certain location. So f of -3 would want to find out, well, is -3 going to work for this equation or this equation? And we would say, for this one, since -3 is less than 2, we would use 1. So we'd get -3 plus 1 squared, which ends up giving us 4. All right, and so forth. So this one will be greater than or equal to 2, so we'd want to use the other equation. Okay, so those should be pretty good. These ones, we need to write down the equation as in a piecewise function. Something like this, we'll want to write it so it looks similar to that. So to do that, we'd want to write down our equations. So here, the first one, we'll just say this, this one we'll say this will be equation 1, this will be equation 2, this will be equation 3. Okay, the first equation is a quadratic, so we'd want to write y equals, and first thing, we'd want to find out what a is. So over 1 up 2, a for this equation is 2, and then we want to find our vertex, h and k, which is the point of our vertex, which here will be -4, 2. So from there, all we need to do is plug it into vertex form. So 2 times x minus h, so that gives us a +4 squared plus 2. So just make sure the equation has a times x minus h. So when you plug that negative h in there, it will make it be positive. Okay? Second equation, this is a linear equation. There's no curve or anything. The slope is constant, and the slope is 0. So we'd do y equals mx, m is 0, plus k, or plus y equals mx plus b. So b here would be -1. So our slope is 0, and our y-intercept is -1. Okay, and then for 3, it's also a quadratic. So here our vertex here would be 2, -3, and our growth, our a value is over 1 up 1. Okay, so we'll plug that in, we'll get y equals 1 times x minus h squared, or minus 3. So we have our 3 equations. We'll want to write it like a piecewise function looks like, something like this. Write down our equations, 2 times x plus 4 okay? And then we want to write down our domain. All right, a little smaller. I'm going to change that to be darker. Okay, so domain is all the x values for each of these individual graphs. So this one will go from negative infinity to 3. So here usually what we would say is x is less than 3. It's not less than or equal to because we have this open point. Okay. And then next one, we'd want to find the domain of this graph. And this keeps going too small. There we go. All right, so the next one goes from negative 3 less than or equal to x less than 2. So all the x values are between negative 3 and 2, and it includes negative 3. And the last one goes from all x values greater than or equal to 2. All right? I mean, there are different ways you could probably write those domains. Like perhaps you would write it as negative infinity, x negative 3. But this is not how we usually write it. It's not the standard. So you would probably want to try and write it this way. I would probably just only take a little points if you did it wrong, okay? Same as this other one. You could write this as 2 less than or equal to x less than infinity, but again, just the same thing. It's not how we write things, okay? And we want to have it as concise as possible. Okay? All right. If you have any questions about that, let me know. 29, here we have a point here. Just choose which one you want it to use it for this absolute value function that goes from here to here, or if you want to have it be for the quadratic that goes from here to here. Same thing with this point. It doesn't show a point, but you can use it. Choose which equation you want it to use with. Okay? All right. Okay, next we need to graph. So here, I like the idea when you draw the domain line. So here at negative 2, we do like a dotted line. Okay, and then we want to graph here. This is a quadratic. It's a vertex form where the vertex is 0, negative 1. And the growth pattern is negative 1. So 1a, 3a, 5a, where a equals negative 1, gives us negative 1, negative 3, negative 5. So we'll go over 1, down 1, over 1, down 3, over 1, down 5, which would be something like there. And we'd connect the dots. The thing is that the domain for this graph is only when x is less than or equal to 2. So we'd put a point here. Maybe put an arrow here saying that it's going for infinity, and we'd stop at that. All right, the next equation we'll do this absolute value function, where here the h and k for this would be 0, 0, our vertex. Okay, and then we'd use our slope for a. So rise over run, up 2 over 1, up 2 over 1, and then we'll mirror over the axis of symmetry. That will be an arrow because it keeps continuing, but this one doesn't include that point, so we'll leave it an open point. All right, and that will do it. If you have any questions, watch the video, come and talk to me. I think that was everything. Okay. And then these ones here, it's not a piecewise function, so that's pretty easy, but you need to write down the domain and range. Okay. All right, so here we want to graph. Well, this is in vertex form. Our vertex is 2, 4. 2, 4 will be right here. And then it's a quadratic, so we'll use it as a growth pattern. 1a, 3a, 5a. where a equals negative 1/2. That will give us negative 1/2, negative 3/2, negative 5/2. Okay, so we'll go, let me zoom in a bit. We'll go over 1 down 1/2, over 1 down 3/2, over 1 down 5/2, over 1 down 7/2. Okay, and we can continue this pattern as far as you want, and it will just mirror over the other side. Something like that. Okay, and then it asks, this is the important part, or not the important part, but one of the important parts, the domain and range. Domain, it's always the same, okay, unless it's piecewise. So this equation will go from negative infinity to infinity, or you can write it as this funky r, or you can write it as negative infinity less than x less than infinity. And then the range, this is not the same, it will change wherever it's at. It's all, for like this one, if we want to write it as inequality, would say it's all y values less than or equal to 4. Or you can write it as an interval of negative infinity to 4. And we'd have a square bracket. Okay? All right. And then the last thing is 34. Just go over some of these examples. So just remember, when you're doing graphs, you want to find the first difference. That gives you, if the first difference is the same, then it is a linear equation. Okay, if it's if the first difference is not the same, if it's not a constant number, we'd want to check the second difference. Okay, if that is the same, then it's quadratic. Okay, and if neither of those are, we'd want to check and see if there's like a multiplication. If we go from one to the other and see if it's multiplication, then we'd know that it would be exponential. Exponential. Okay, and if it's not any of those, then we would say other. Okay, or none of the above. Okay, so let's look at some of these. This one, we could look at this first and say, oh, it looks like that's half. This is half. Each time it is multiplied by 1/2. Okay, so you just have to kind of practice, look at stuff, see if you can see a pattern that's going on here. So this would be exponential. Exponential. Okay, you may see problems on here that, let's find another one that you may think may look like exponential. So here, you can always find if it's exponential by like dividing what's before it. So if you did 0.8 divided by 0.32, that would give us, we'd multiply it by 2.5. Okay, and let's see if that continues. So 0.8 times 2.5, that gives us 2, so that is multiplied by 2.5. This one, though, when you multiply that by 2.5, 2 by 2 times 2.5, that gives us 5, so that gives us 2.5. All right, I think I was a little off. So this one, 5 times 2.5, we're still there, 2.5, and then we'll do the last one. 12.5 times 2.5. That does not give us what we want. So this does not continue this pattern. 2.5 divided by 12.5 is 2. So you multiply 12.5 by 2, that gives us 25. So here, this tells us that this equation, perhaps it's a piecewise function, I don't know, but it is not exponential. It is, we'd say other. Not other, we just read it as other. Okay, does that make sense? So some of these, you'll need to look and check all of them. You can't assume, you can't just go through these first problems, or 3 or 4 of these, and say, oh, the rest must be, it must be exponential. You have to go through and check, okay? So exponential, let's look at a problem that's linear. Like here's another one. It doubles, 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 but this does not double. That continues to double. So this one, from here to here, that tells us that it's not exponential, okay? But it's close. Let's look at 5. So here, looking at this, 2, a half, 0, a half, 2. So you're thinking, well, since it goes down and then it goes up, we're thinking quadratic, but let's prove it. So first difference, that gives us 1.5, or a negative 1.5. Difference here is negative 0.5. Difference here is 0.5. Difference here is 1.5. And here the difference is 2.5. So definitely not linear, because if it's linear, these should all be the same. So let's take the second difference. The difference between those two is 1. Difference between this is 1. Difference between this is 1. And difference between those is 1. So since they're all the same, this would be quadratic. And that would be your answer. Okay, and then let's look at 7. So here you can see the difference here would be 1, difference here is 1, difference here is 1, difference here is 1, difference here is 1. So since they're all the same for the first difference, it must be linear. All right, so there you go. See if you can do the others. Like I said, the answers are on the back. Also, I want to remind you guys, please do the problems first, then check your answers. It's tough for me because there's no point in you doing the problems wrong, and if you don't know that they're wrong, then it's not going to help you on the test. On the opposite side, if you just look at the answers to find out how to do the problem, that's not helping you either. Okay? So please do the work first, then check your answers. Ones that needs to be fixed, 15. This should be 7 or negative 7.66. All right, but this is still your answer. B would be your answer. 20 and 21, these need to be switched. 21, 20, 21. Okay, I already switched it on this one, but on the test, it needs to be switched. Okay, or not the test, your paper. This should be switched. So this is correct how it is here, but you need to fix it. What else was it? Oh yeah, on 3, I fixed it here. I wrote down that there's an error, but I already told you at the beginning that it's being compressed by a factor of 1/2. On the problem, it says that it's compressed by a factor of 2. So fix that on, not on your answer sheet, but on the problem. And last one is 24. Okay, A is correct. B and C, these are correct, but you need to fix it and put it in as 33% and 152,240. So if we look at 24 really quick. Okay, so the answer that you have for the problem is when you said that this would be your rate of change, if you said it was 10%, if you did not take care of this number. Okay, and that also affects the cost after 20 years. Okay, so there you go. If you have any questions, please let me know. If you have any suggestions about videos, let me know. If this makes sense, if this helps you, please let me know. Otherwise, I may, if I feel like it's not helping anyone, I'm not going to do this because I did this already once today. The first try didn't show the sound, so I redid it. Next time I had difficulty with my pen, so I had to start over. So basically I've spent like 3 hours trying to do this video to help you guys. And if this isn't helping you out, let me know, please. And if you like this video, give me a thumbs up or make a comment about how you liked it. Okay? All right. Good luck on the test.